Hi everyone, this is your learning coach Vinod, and I'm really happy to meet you all today. So, after a very long break, I think it has almost been like a few months since we did a live event on astronomy. So, really happy meeting you all guys here. So, hi everyone. So,
Hi everyone, this is
nice,
your learning coach.
superb guys. Hi Parisa. Hi Immaculate. Hi Danshika. Hi Prashit. Nice. Hi Nivashni. Superb, guys. So before we begin this masterclass, I really want to thank a few people as we start. So the first one would probably be Lotus International School. So they are the sponsors for this event. Really happy that they are able to be here and not just be a sponsor, but also have all their students here. I also want to thank Amrita Vidyalayam School. So they have also kind of like informed this program, and I see a lot of students from Amrita Vidyalayam joining here too, and really happy for all my old students, all the Space Science Learning Club members and the iSKY Astro Club members from last year to be here. Really nice. Superb, guys. Today we are, embarking on a very important day. So today is the 77th Independence Day. We are celebrating 76th year of Indian independence. It's kind of like a really great moment. If not for the sacrifices, if not for the kind of like hardships that our forefathers have gone through, the freedom fighters, we would not be enjoying such a kind of a great place to live. Okay, so I've heard stories, I have read books where they say the pre-independence India was kind of like a chaotic hell to live with. Okay, so today we are kind of like enjoying all the freedom. It's because of these freedom fighters and our forefathers, and really grateful for all the hardships that they have been through, so that we are enjoying the life that we know of. Okay, so as we begin this session, so can you guys share with me who your favorite freedom fighter is in the chat box? Who your favorite freedom fighter is in the chat box? Very good afternoon to all of you guys. Happy Independence Day, Parisa, to you too. So yes, Immaculate. So we would have been under the British control. A few years back, I played a game. So the game where there would be a dictator in the room, and the dictator would kind of like tell us what to do inside the room. So imagine today it's kind of like really difficult when somebody tells us things and we do that. Okay, it'll be kind of like irritating. Why do you have to tell me all the stuff? Whereas a dictator, humiliates you so bad that you feel like it's not worth living your life. So living a life of a slave was what we did for a few hundred years of British rules. So today we are living a very peaceful and a life filled with freedom. Bhagat Singh, Bardiyar, Mahatma Gandhi, okay, Netaji, Chandrasekhar Azad, Netaji Subhash Chandra Bose. Very nice. All of them are your favorites. Nice. Kritik says all of them. Okay. Example of a dictator is North Korean president. I think there are still about 10, 12 dictators there. Okay, so Tirupur Kumaran, nice. Who else? Come on, guys. Come on. You guys have said about like 8, 9 freedom fighters. More. I need more. We have covered the usual. Sarojini Naidu, very nice. Sarojini Naidu, Sardar Vallabhai Patel. Okay, Sukhdev, Maulana Abdul Kalam Azad, very good. Tipu Sultan, nice. Jawaharlal Nehru, our first Prime Minister. Very good. Who else? Okay. Jhansi Rani. Nice. Jhansi Rani. Some of you guys kind of like go hard and say I love all of them. Hey, come on, you got to love someone more than the other. So you cannot be like I love more of them, huh? Alluri Sita Ram Raju. Okay, I know RRR was loosely based on his life. Okay, Jhansi Rani. Okay, Khudiram Bose. Okay, come on, Aaron. Hitler was not our freedom fighter. Veer Savarkar. Okay, Rajguru. Wow, Chidambaranar. Nice. Lala Lajpat Rai. Bal Gangadhar Tilak. Mangal Pandey. Nice, man. Bahadur Shah Zafar. Superb, superb. A lot of you guys. Dr. APJ Abdul Kalam was not a freedom fighter, unfortunately. Okay, he was as patriotic as you, me, and everybody else, but unfortunately, he was not a freedom fighter. His great great grandfather was a freedom fighter, I believe. Okay, if I'm not wrong. Superb, superb, guys, superb. So really nice, talking about freedom fighters. I hope that one day we should do an exclusive show just to talk about freedom fighters. I'm a history buff. You guys know a lot. So I do read a lot of books about our Indian freedom struggle. So I've collected lots and lots of data, lots and lots of interesting stories about the Indian freedom struggle, about these great freedom fighters. Of course, a few of them are kind of like my inspiration. So I have a photo of Gandhi, for the life that he led. So one of the biggest aspirations that I take from Gandhi was that I told you guys, I think at least a million times I would have told you, but let me tell you one more time about Gandhi. So there is this inscription about Gandhi in the American Parliament. When you hang a picture of a leader, so there are about 100 pictures being hanged in the American Parliament in the launch there, and each and every picture would have the birth year and the death year. So even for Benjamin Franklin, the called as the father of the American Constitution, so you would have the birth year and the death year put up under the picture. But under Gandhi's picture, so it is written that one man can make a difference. So there's no death, birth year and death year. So just a saying that says one man can make a difference. So if Gandhi as one man can make a difference and kind of like inspire millions and millions, I think probably millions is wrong, inspire billions of people to take up satyagraha, billions of people to say, hey, this is a way of life that can be followed by others, then I think that there is potential in each one of us to be a Gandhi and inspire billions of people to do much bigger and much better in life. Okay, so that's the power of Gandhi that we see in our everyday life. Okay, so really happy to see you guys comment a lot about freedom fighters. So today is another special day. We are going to launch the iSKY Astro Club. So today's agenda is going to be, we are going to have a workshop on astrochemistry with Mr. Soham. So I'm going to bring him on stage and we're going to have a small conversation, and then I'll hand over the stage to Mr. Soham. So and after his workshop is done, we are going to do a small I'm going to brief you guys about what the iSKY Astro Club for today is going to be. Okay, and then we are going to play a small Kahoot session. Okay, so that's the plan of action for today. So without further ado, let me bring Mr. Soham on stage. Hi Soham,
Hello, sir. Good
how are you?
evening. Good afternoon, everyone. I'm great. What about you?
Superman, Superman. So first of all, I want to thank you for being here, Soham. So one of the things that I really like about you is that you are kind of like inspired to take up the role of a science communicator at a very young age. How old are you?
I am right now 19.
19. See, so I'm probably twice your age, and I started very very late. Okay, so I am really really happy to see very very young guys like you take up the role of science communication, because I feel that you would be able to connect with the kids much faster, much better than someone of my age. Okay, so really happy to have you here as a fellow science communicator. So can we start with a small self introduction with you? I'll tell you what I wanted to know. So I wanted to know how you became a science communicator. So what are the things that you are doing? So he's also the founder of Astronautic Institute. So how did you come about that? So we'll have a small talk about that, and then we'll get on to astrochemistry. Okay.
Well, this is actually a very interesting story, but I will cover it up in a large way or in a very informative way when we will get some time more regarding the things. But for the initials, let me tell you that I started like I had an interest in astronomy since the grade of second. So since second grade, I was having very interest, and the very basic grade it was like that. My sister, my elder sister, I'm having my elder sister. So she was teaching me the name of the planets which are there, and there was like from her textbook itself. So from her textbook it was written like in 2006 the Pluto went out of the solar system because it is a dwarf planet. It doesn't reach the criteria of being a planet. So I got curious that what is the criteria of being a planet, then why this is called a planet, this is called a dwarf planet, what is the difference. The basic question which I was having is what keeps this planet in one particular orbit or in one one place, or it goes around the sun. So what might be the cause? Then till 8th standard, I was just doing some stuff. I did some robotics. I went into some electronic projects, some kind of ATL, Adult Tinkering Labs, which is there. It was there in my school. So I did some good projects over there. I learned some basic electronics, and after that, I again came back to the astronomy. Well, I actually tried to bring it on the official one. So I tried to enroll myself in a particular Olympiad, which was actually powered by JAXA, Japanese Space Agency.
Mhm.
So well, after some tries, or there were three levels, so I cleared all the three levels, and then I became astronomy scholar. Well, this happened in the when I was in 12th. Or I was already started working with a company called as Laksha Space, which is there in Bangalore. When I just cleared my 10th standard, I went into 11th. So at that time, I had a talk with them. I had a basic talk with them, and they kind of like took me in their team. I was very grateful at that time. So for 3 years till my first year or something, I continued the work, with Laksha Space. And then we got an idea that, like, hey, for example, there are many students which are there now. Laksha Space is a research company. It is for elder students. So I thought that there are many students of my age or even younger than me, because when I was younger, there was no one to guide me. There were even the relatives of my family were telling that there is no scope in astronomy. You can't do anything in it. There is literal you can just you can't just do anything over there. Or even if you try to do, there will be crores and crores of rupees which will be invested into the thing, which we don't have, being from a middle class background. So well, from step by step I thought that why not to give them guidance, because I know what is exactly going on in the corporate or in the organizations of space domain which are there, how companies are small, building from scratch or even from no funding, from bootstrap funding to the particular MNCs which we are seeing right now. That Skyroot is there, Agnikul is there. So these kind of companies, companies which are there, they build from scratch, and now we can see that where they are. Even Jet Aerospace is one of them. So that is how I got to know, and well, then I thought that why not to build an edtech platform of Astronautic Institute, which we thought. So it has just been like 5 to 6, not more than 6 months actually. It just has been 5 months since we started that particular edtech platform, and it is going well enough. We are having a bit of community. So yes, we are few searching that how the future endeavors will go on, and well,
Very good.
I actually really pray to you guys that the way these students are interacting with you, it is really good. I was watching all the chats from back there. I was feeling really great that the interaction which is going on. So I really hope the really well good for these students as well, and for the launch space thing as well.
Yes, man. Yes, man. So, what I really think that you're doing in the right direction is that starting up when you are in your college. Okay, so started an internship. I hope the one that you did with the Lakshya was an internship. So started an internship as soon as you finished your 10th grade, and started your business as soon as you started your college. So that's the way to go about it, so that you can make all the mistakes well before you are 20, and you're get set to rule the world from 21. So guys, for all of you who are listening to this, this is exactly how you could, how I feel that you should do in your life. So as soon while you are there in your school, try to get an internship. So at some company, at many companies, okay, every year you can do an internship there. So as soon as you get into college, first thing that you need to do is, start your own business. That's really nice. Okay, okay, so I'm going to leave the floor to you. So as soon as you finish, I think in between, if I have questions, let me just come by the stage and ask you those questions that kids are asking in the chat box. Guys, I would want you guys to not spam the chat box. So let's look at what Soham is going to teach us, and probably start asking questions from there. Okay. So every now and then, I would be glad if you can just take a few questions from the chat and then go on with the class. Huh?
Indeed, indeed, surely.
Yeah. Yeah.
So yeah, thank you, sir. Thank you very much,
Thank you.
Vinod sir,
Yeah.
for giving me this opportunity. Well, hello students. Good afternoon. How are you? I hope you are doing well enough. So today we are actually going to have an astrochemistry class, which is actually basically this astrochemistry is a very different topic from the usual things which we do. Like this is like we all know about astrophysics, we all know about astronomy, we all know that how theoretical physics goes. But this astrochemistry, it is a bit different, right? So it is having a bit gyps of chemistry and astronomy both, and we are going to learn that how engineering marvels were created using this particular concept, how we are going to learn something new based on astrochemistry, how applications of astrochemistry are also there in the quantum mechanical part. So I am going to give you a bit a small glimpse of this particular webinar. Now let me clear out one thing. As Vinod sir started the webinar with a particular question that today is our Independence Day, and which is the favorite revolutionary, freedom fighter for you all. So let me just give you from my part. I personally adore Veer Savarkar and Sunetaji Subhash Chandra Bose. Just a particular point. So now let me get back to the topic. Well, first of all, let me ask you that what do you think, according to you, is according to your understanding, that what is the exact definition of astrochemistry? What might be the definition of astrochemistry, or what do you understand from on your own lookout? What might be it? So just let me know that how it goes. So till then, I will start giving you a particular glimpse that how the webinar is going to go. Let me give you the index page, that how are we going to follow the session today. Okay, so just a second. I hope my screen is visible. So whenever you have any question, whenever you have, whenever you want to clear out something, or if my voice is not audible, or you want me to give you more information regarding this, so you can anytime put it in the chat box. I'm having a constant view, okay, and on the chat box. So yes, so astrochemistry is the study of abundance of reactions and molecules. Yes, from the universe lookout, that is the correct definition of astronomy and chemistry. So yeah, so let me show you that how it goes. So now, index page on today, what we are exactly going to learn, okay, and what might be the points, what are the major points of this particular webinar, what is the purpose of this webinar to make you learn about it, right? So now, first we will be getting on to the definition and the major practical things. What is astrochemistry? There are also some types of it. So I'll be telling you that what are the types, okay? And well, now then they will be now every one of you might know what is chemistry, right? You all know what is chemistry. You all learn it into your textbook. You're having the independent textbook of it. If anyone is here from 11th or 12th standard or giving JE or NEET, you must be learning about chemistry, right? Okay, so even from any background you are, like it might be science, it might be engineering, it might be biology, it might be any other field, okay, even from civil, the base of the starting initial standards of it, the starting initial years, you have to learn a basic chemistry or the base of it. Now we will be getting the difference between chemistry and astrochemistry, right? Now from next point, we'll be learning from big bang to dark energy, right? You all are the basic agenda of every astronomy lover or every astronomy passionate enthusiast is that you all are starting to learn or to gain the information. It started from the Big Bang, from the black holes, from the theoretical physics, or even from time travel. Like time travel or the aliens. That is the basic. That is actually the very very basic concept of how this particular the astronomical enthusiastic journey goes, right? So we are going to learn about it as well. So if you have any other information, you can always tell me. Okay, now you have to be very very interactive with me. That is my first point. Okay, I am I don't, and first of all, don't call me sir in the chat box. You can just call me Soham. Okay, so I am just a bit elder than you, not of your age. Okay, so so now applications of astronomical, we astrochemistry, we are also going to learn about it. And yes, that is a very, this particular last topic which is there, a brief information on SETI. Now this is, I have added it for your own knowledge gain, or for your interest part, that how aliens can be detected, or how aliens can be found. What is the what are the like scientific evidences, or what are the scientific advancements into that particular journey. Okay, so that is very very important time. And then at the last we are going to have quiz time, as told by Vinod sir in the Kahoot, right? So let me start. Okay, let's start with the webinar. Okay, just give me a thumbs up, or a big red heart, and we are good to go. Okay, so so first of all, we are going to have an introduction to the astrochemistry. Now, what might be astrochemistry? What is the agenda? What is the reason? Because you all know that astrobiology is very much needed for the basic advancement of life. Like, you need to know that how plant grows from a particular seed after the nourishing of the plant, right? So that is called as astrobiology on the cosmic level. Like, for example, there is some other planet from the Earth, right? There is a different planet than Earth. So if there is some different planet on the Earth, if it is having a proper atmosphere, if it is having a perfect light, heat, and everything, then basically what we have to do is, we need to analyze that. And for that, what we need, we don't need physicists for that, we need biologists for it, we need botanists for it. Okay, so that particular regime need to be followed with a particular branch which leads to a birth of astrobiology. Okay, now there are many many branches which are actually connected with all these sub branches. Okay, astronomy is a kind of branch. Let me just do the marketing of astronomy over here from this platform. Okay, astronomy is such a branch which includes each and every topic from the whole world. Okay, like for example, let me give you an example. Okay, now there is TCS, like okay, Tata Consultancy Services. Fine. So Tata Consultancy Services, it is basically a tech company. Okay. Now we need tech, we need AI, like artificial intelligence, we need ML, machine learning, we need AR, augmented reality, we need each and every aspect of data learning, data science. We need big data, we need data analysis, we need each and every field which is there, which is present over here. Okay, which is present on this platform of Earth today. Okay, so we need each and every, and as soon as any other branch of biology, chemistry, physics, finance, or or astronomy, or technology, or each and every sector, as each and every sector grows, any revolutionary thing happens in any one sector, the profit goes to astronomy sector only. Because each and everything, you need civil engineer for your astronomy, because you need to build the rockets, you need mechanical engineer to analyze those particular blueprints of the rocket, you need software designer to design the rocket, or to make the blueprint of the rocket, right? Then you need a builder, you need each and every person, right from a plumber to the welder. You need each and every person in astronomy field. When it comes to execution of each and everything, you need each and every field, each and every aspect of life which is need to be followed. Okay, then you need scientists, of course, scientists. Then mathematicians, naturally, because if how much the diameter, or the o-ring diameter, how much fuel is needed, what is the, how many kilonewtons of the thrust is needed. So each and everything is analyzed in the field of astronomy. Each and every branch is there in astronomy. So astronomy is a very very growing branch. If you see, last 5 years ago, there was almost no company which was known to any particular individual apart from ISRO. Okay, and now you look today, there are more than 120 companies which are cooperated and inaugurated in the there in India. And most of the companies are here either situated near Tamil Nadu or Bangalore or any other, or in Kerala or anywhere. Okay, so these are the hubs, next coming hubs, or the very very mega factories of astronomy, which is going to build the the next structure, or the base is already built, because ISRO has done a marvelous job in the field of astronomy. Because Chandrayaan 3 right now, as you can see the updates of Chandrayaan, right? So Chandrayaan 3 is there, which is going on. Mangalyaan we have gone for. Aditya L1, which is a mission, which is going to go to the sun to analyze the atmosphere of the sun, is also getting built, right? There are images which has been launched by ISRO yesterday itself. So these are constant updates which keeps on coming. So we need to analyze those. There is a lot to learn. Okay, we just need to have the enthusiasm or the particular knowledge. Okay, for the enthusiasm, or the will to learn. That is something which is very much needed in astronomy. Okay, so now let's start with our particular PPT. Okay, let's start with our introduction to the astrochemistry. Fine. So now, what is exactly astrochemistry? Now, astrochemistry is the study of molecules, which is basically nothing but the chemistry on a cosmic level, on a celestial level. For example, here you can see the pictures. Okay, here you can see some of the pictures. Okay, now the pictures which are here on there is one big picture and there are two small pictures. Okay, now let me give you a really good information or elaboration on these pictures. Okay, so the picture over here, the big picture is over here, is of a nebula. Now, any one of you, what is nebula? Do you, any one of you, can you tell me what is nebula from your lookout? Like, what is nebula exactly? So nebula is nothing but a stellar nursery. Okay, now notice what is nursery? Nursery of the
Soham,
kids are.
Soham, I'm
So
sorry.
the particular thing is,
Soham, I'm sorry.
yes.
Your screen is still in the first slide. Yeah,
Okay. Uh, okay. Have it. Is it gone to the second one right now,
yeah.
or?
Now it's in the second one. Yeah,
Okay, fine. Okay, great. No worries. Okay, so how we were on the stellar nurseries. Now, what is exactly nurseries? Nurseries, that nurseries are like the kids' nurseries. Yes, exactly. The nurseries where small students learn. The small students are going every day to learn. Okay, those KG1, KG2 nurseries I'm talking about. The nurseries which are there for human childs are also the nurseries which are there for stars. Now, what kind of star? The small stars. Now, of course, nursery. I won't go to a nursery. Okay, Vinod sir, as he's not going to a nursery right now. Okay, so the same way, the stars like sun like star, it's a young star. Okay, the young star is there. Sun is a younger star. Okay, very young. It's in the primitive age of its youth. Okay, it's filled with energy right now. So the stars which are very small, which are called as protostars. Protostars are the stars which are on the phase of evolution. Okay, they are on its way to evolve. Okay, on to grow. So those are called as protostars. Those stars are the stars which are made is called as stellar nurseries or the nebulas. Now, each and every dot which you can see over here is a star. So you can imagine each and every dot. Can you count the number of stars over here? Can you count the number of dots on the screen? Yes, can anyone count the number of dots? And if it's so, are you going to take more than 2 hours or more than 3 hours? That is my question. Okay, so moving forward to this particular thing. So the to analyze this particular dust, to analyze the temperature of the star. Now, for example, let me give you a particular analysis that how the temperature of the star is analyzed. Now, there is one graph. Okay, there is one graph to analyze the temperature of the star, to analyze the luminosity. Now, luminosity is a physical concept or a physical entity. Okay, which is actually analyzing that how bright the star is. Now, we all know that there are 4 watt of bulb, there is 12 watts of bulb, there is a tube light. Okay, there is 80 watts of charger as well. So the bigger the the bigger the number of the watt, then the bigger the the capacity of the tube light or the bulb it is, right? So the same concept is used here. The more the luminosity in Kelvin, the more the luminosity will be there. Okay, the more the luminosity of the star will be there, the more bright the star, the more color of the star is different. So can anyone tell me over here what is the color of the sun? What is the color of our sun? Okay, so yeah, no, it is not lumens. Okay, Prasad, it is not lumens, it is luminosity. Okay, the luminosity is a different entity. Okay, So yeah. So my question was, can anyone tell me that what is the color of our sun? Like as you can see, what is it like? Let me give you an option. Let us play KBC, kaun banega crorepati, right? So what is the color of the sun? White. Yes, very very good. Before me giving the options, really you are incredible audience, very good. So so the first thing is the color of the sun is white. Yes, that is very very true. No orange, no yellow. That is the most common answer. Okay, so the color of the sun is white because you can't see, you can't see. If you go, first of all, if you can, if you go to the space, okay, if you go outside the atmosphere of earth, okay, you can see that the sun is there is in white. It is not there in yellow, it is not there in orange. Or there is a reason why, because there is one particular concept called as atmospheric turbulence. It is used in physics. If you are there in 10th or 11th, you might know about it. The atmospheric turbulence, it actually causes the the viewing, the color to change. Okay, the first of all, it is let me give you a very basic definition for this: refraction. Okay, because of refraction, as the sun, for example, this is the light. Okay, this is our earth, and this is the light which is coming from sun. Okay, now this light is coming as soon as it touches the atmosphere, okay, or the ozone layer. Well, ozone layer is very very inside. Okay, so I am not going to say ozone layer, but the atmosphere, the initial level of atmosphere, when it touches the initial level of atmosphere, it bends. Okay, so after it get bends, it is it refracts itself in different kind of lights. And the most viewed light, or the most the most visible light to our eyes, or to or the visible most entity, is yellow. Or when it goes in the sunrise or the sunset, it can be orange or even red. So only there is one concept called as apparent position, and one is original position. Now I won't go in depth over here, it is a physics part, so I will leave it over here. But let me tell you, the prism is there, right? So when the light comes over the prism, it bends, and a rainbow is formed. Okay, so the white light contains each and every light of the spectrum. Same way, you are only able to see the yellow light, okay, the red light or the orange light, okay, because of the wavelengths, because the particular wavelengths which are there. Okay, now let us move forward. So where I was, the astrochemistry which is there, you have to analyze all these particular things. Like for example, what materials the star is made up of, how it is looking different in color. Okay, for example, let me give you a very good example, extremely good example. Okay, now you all know the poles of earth are there, right? Like arctic, yes, dispersion of light is there, yes, it's true. So let me tell you that poles of the earth are there, right? The poles of earth, now poles of earth are there at arctic and atlantic, right? The south pole and the north pole, fine, there are two poles. Now when you can all see that there are very very different kind of things which happen at the poles but doesn't happen at the equator or near any other country. Okay, the country which is near the poles can experience it, but no other country or no other part of the earth can experience. It is called as the aura, or the or to be more precise over here, it is called as the aurora borealis. Aurora borealis is a concept of aura. You have all seen that light, which is wavy pattern kind of thing, like green light, or for example the the blue light is there, even there is rainbow colored light is there at the present at the poles, the aura is there. So these are all the concepts. This how it happens that at some point aurora lights are there, some point the color of the lights is different, like sometimes it is blue, sometimes it is green, sometimes it is rainbow. Okay, so how it is different? Because there is one concept. For example, if there is nitrogen, you can see the green one. If there is oxygen, you can see the green the blue one. So these are the different things there. If there is some other kind of, if there is sulfur, you can see the yellow one. So these are all the entities. This is how the particular physics or astrochemistry of the physics, okay, the astrochemistry is applicable over here, right? So this, for this particular to analyze this particular thing, we need astrochemistry. Okay, so let's move on to the next slide. So now, hey guys, so there are three parts. Okay, the astrochemistry is also a sub branch. Now let me tell you, there is physics. Okay, now there is after, sorry, astronomy is there. Now
But yeah, I'm
astronomy,
sorry.
you can actually make a very good flow chart
So,
over
so
here.
I'm sorry. There is some glitch, and I think you need to redo. Yeah, the slides alone. Yeah, yeah.
Okay,
Now we are here in the third slide. Yes.
okay, fine. So, guys, was I was saying this now. Astronomy is actually like it can be divided into three parts. Okay, like, you can actually make a flow chart of this. Like for example, one is astronomy, right, on the top. Then you can make three sub branches of it, right? Astrophysics, astrochemistry, astrobiology. Now, also below astrochemistry, you can make three parts over here. Now, what are those three parts? I will make you understand over here. The number one is laboratory astrochemistry. The laboratory astrochemistry is actually really, really interesting because it is based on the practical implementation of the astrochemistry part. Now, how? So, for example, you all might be doing the chemistry, right? Some many of you have been to the labs of your schools. Maybe all of you have been to the schools of the lab is there. So you might have used a beaker, you might have used a pipette, you might have used a flame which is there. The flame pot which is there. You might have used the china ball. So you all have used that particular things, right? So the same way, but on a very, very complex level, you are going to use the astrochemistry, laboratory astrochemistry. Okay, now it depends as so. For example, we write the experiment, right? Aim, apparatus, diagram, procedure, and then we go for like observation, and then we go for the conclusion, right? This is how the chemistry or the how this is how the particular experiment goes on. So the same way laboratory astrochemistry performs, but in what sense? In how they analyze, what they analyze exactly in the laboratory. Now, because we are talking about here in the astronomy, then what are they doing in laboratory? They should be there on the grounds. They should be there in space. Then what are they doing on Earth? Now, this is a very good question if you ask me. Now, the answer to this particular thing is that the direct samples which are collected, for example, aurora is there, right? I gave you an example of aurora borealis. Okay, like aurora lights are there, northern lights we call it. So they what these particular thing is, there are laboratories in the on the poles. Okay, now what they do is they try to put their sensor, or they try to put their their subatomic particle catcher as well. Okay, many times those particles which are there, those are called as subatomic particles. Okay, they are traveling with 99% the speed of light. Okay, they are light, this they are light, but there are many other different particles which you need to analyze. For example, there now what are the basic particles there in the atom? There is proton, there is electron, there is neutron. Fine, these are the three basic particles which you all have heard about. Fine. Now, the thing is that what I can tell you is like there are more than 15 particles. Okay, there are more than 15 particles in subatomic world. Then how you will say you have never learned about it? So you might have, there is a field called as quantum mechanics. You might have heard about this. Okay, quantum mechanics is a very, very interesting field. Okay, now there are particles of that. The quantum particles are there. For example, the protons.
So
The proton.
we have only heard about all these things in Quantum Nia,
Okay, I
Ant
see.
Man and Wasp.
Okay, I see. So that's that. Of course, Marvel is a very good marketing, of quantum mechanics. It does a really good marketing of, quantum mechanics. But let me tell you guys, whatever you learn from Marvel, okay, that is always incomplete knowledge. So never ever believe in incomplete knowledge. Okay, you have to be really very elaborative with this particular thing, or you need to be thorough with it. Okay, so that's a very good thing. Now, so let me get back to the part. Then protons is also made up of some kind of particles. Okay, now if we go on a smaller level, right? So atoms is there, then proton is there, then proton is also made up of some particles. So there is also those particles are also made up of some those particles. So this is how it goes to analyze all these particles on a quantum level. Now, what is quantum? What is the meaning of quantum? By the way, I'm saying since last 5 minutes, quantum. What is meaning of the quantum? So how you will elaborate that, what is exactly the quantum particle, or the quantum gravity, quantum fluctuations, quantum physics? All these are very, very exciting fields. Quantum computing is recently in very much in discussions. So that is actually a good field which is going on, and you guys know about it. Well, at least you know the names. I didn't even knew when I was of your age. So it is actually really interesting to talk to you with this. But okay, I'll connect back to the astrochemistry. But I need the answer from you, that what exactly is quantum? Yes, someone answered it very, very right. The quantum means the study of the extreme small. The study of small is called as quantum. Okay. Now the mechanics, the how mechanics means how it functions. The study or how the functionality of how the smallest particles work. That is called as astrochemistry. Sorry, that is called as quantum mechanics. Okay, the physics behind the smallest particle is called as it is called as quantum physics. Fine. So now, laboratory astrochemistry is all about quantum, is all about modeling, is all about making the really big structures and all. So let's this is how the laboratory astrochemistry is there. Now I if any one of you is there, if any one of you is interested in this particular part, I really encourage you to go over here and be an astronomy or be an laboratory astrochemist. This is a very very good field and interesting one where you can make
Buddy, one
revolutions
more
to
time
come.
your screen.
Okay. Now,
Your screen share one more time. Yes, thank you.
okay. Yeah. So this is called as observational astrochemistry. Now this is actually more related to the theoretical part where you rely on your eyes. What are you watching exactly? And then you believe on it. Now there is one kind of small flow chart is there. You know that how the the journey of a star, how it is made. You know how it goes through its life. You know, like the lung star is made, then the planetary system is made, then it becomes, it evolves into its particular regime, then it gets into the diffuse star because its life ends, you know, it gets old, it burns, it dies. Then we have, because of its particular immense gravity, its immense energy, a dense cloud is formed, which is also called as nebula, as I told you. So then a protostar is born. You know the nebula. The This is a picture which I saw. Yeah, this picture. This is also a nebula where new stars are actually forming over here, right? So this is how it goes. Now all of this, how it happens, what are the combustions which are going on over here, how they are going to react with each other, how they are going to be with each other, right? And how they are going to connect, how they are going to die, and you know after they become in the cloud format, which is the most abundant element over there, right? So these are all the things which we need to analyze, and that is done by observational astrochemistry, right? So this is how it goes. And yes, so now third part, which is theoretical astrochemistry. I want answers from you over here, that what might be, according to you, what might be the job of theoretical astrochemist be? Okay, like for example, as you learned over here, right, the laboratory astrochemistry is over here, right? They perform experiments. Okay, they perform the particular the analysis of things. Now on the observational astrochemistry is over here, they observe the things, they look into the universe with their eyes, they get those data, they get that data which is there, you know, like they get the statistics, you know, they get the statistics over that. So that is how it is actually that is how the observational astrochemistry do. Then what is the job of theoretical astrochemistry? Okay, so now theoretical astrochemistry, someone said that it is built on observations of astrochemistry, astrometry, astrochemistry, and astrophysics. Very very accurate answer. I want, like, if we were there in the offline class, I would have clapped for this answer. It was really very accurate, that all the data which is actually gathered or observed or experimented by by laboratory, by observations, it is all gathered, or it is all analyzed, it is all performed, all it is all it is all like separated according or executed, and then how the execution should go, how this perfect experiment should perform, it is all done by the theoretical astrochemist. And it is the job of astrochemistry, theoretical astrochemistry, to provide. Okay, is actually very good and really good answers. Chemical compositions and processes for stars, this is also a very accurate answer. This is actually that how the compositions are made, you know, that how, for example, there is one discrete packet of cloud which is nebula is there, right? So nebula is there, then what are the elements which are there? Like, for example, methane might be there, but there might be abundance of helium. So we can analyze that in the coming million years, a few million years, many stars might be born over there, right? And that stars might be of this particular color, because there are colors of star as well. Okay, there is called an HR diagram, Hertzsprung Russell diagram is there. You can actually see that over on the net. I will not go in depth of it, but there are that how, what type of star it might be, how big that star might be. These all things are done by theoretical astrochemistry. Okay, so very good. That is how it should go. Okay, and yeah. So now, how is it different from chemistry? Now we are here on the part where we are now enough having a knowledge that we can define between what is the difference between the pipette and acetic acid solution which we perform, then the, you know, the reaction between HCl and your H2SO4 and your particular weak base, acetic acid or something, and then you create a salt out of it, the weak base strong acid, something you do, right? So these are all kind of laboratory experiments. So now we are having an enough knowledge that what is the difference between chemistry and astrochemistry. I hope I'm clear. Please give me a very good thumbs up or a good red heart so that I will understand that you are all getting it right. You are all understanding what I'm trying to say or trying to explain. Okay. Now, what is exactly there is that chemistry is just a laboratory experiment which is done just to get the samples of it. Okay. Astrochemistry is actually a bigger entity of chemistry which is performed on a celestial level, as I said in the very beginning of the webinar. Okay. Now, the thing is that study of actually there is one more term called as cosmochemistry. Okay, now the cosmochemistry is there. This is nothing but like astronomy is there, right? Cosmology is also a term which is actually a Russian term. Okay, now the cosmology comes from the term cosmos. Okay, so cosmos means nothing but the observable universe which is there. So cosmochemistry is nothing but a synonym of astrochemistry, but cosmochemistry is actually the chemical study of the solar system. Like for example, let me tell you, your particular HCl, H2SO4, acetic acid, and your NaCl and all kind of these salts and bases and acids which are there. These are actually only for a particular surrounding. It is you are going to perform it, right? You have phenolphthalein indicator, methyl orange, everything, many things are there. Okay, so these are actually the laboratory chemistry experiment which I'm trying to talk about. Okay, now there is astrochemistry which is there, like all things are about astro, the observational universe is there. There is the other galaxies which are there, the other galaxies, other nebulas, other local groups, other super clusters which are there. So all this study comes under astrochemistry. But when it comes to analyze the chemical format of your solar system, Jupiter, Saturn, Uranus, Neptune, even Pluto, Oort cloud, asteroid belt, Mercury, even Sun. So all these formats are covered in cosmochemistry. Okay, so like for example, the study of we are actually studying right now the moon of this Europa. The Europa, we are studying that there is ice on Europa, so there might be water. We are studying Mars, we are studying Titan. We are also studying that how that how the diamonds, there is one fact which is there, fact, one fun fact for you, that Jupiter, the rain on Jupiter occurs not with water. It happens on it rains diamonds. Okay, diamonds rains on Jupiter. It is not water because of the extreme pressure and the density which is there. You can all see that that diamonds are actually raining on Jupiter, not on Earth. Okay, Earth is not having that much density, that much gravitational power which is Jupiter is having. So all this study, how did we got it to know about it? Because we have sent some spacecraft, we did some study, and all kind of things. So that is called as cosmochemistry. Okay, so that is how it goes. This is how the difference between the chemistry and astrochemistry it is. I hope Triton will die. Well, this is also one of the fact that Triton will die. Someone is saying in the chat box. Well, it is. We can discuss this some other time. It is actually also an interesting issue over there happening in our solar system. So now let us get back to a very interesting topic which you all have heard since the very start of your life. Since that is there is the initial topic that how we actually the start our journey in astronomy or the being an enthusiast in astronomy. You know, so usually it is the topic of black holes, but always after black holes it is the Big Bang. That how the Big Bang occurred, what caused the existence of human, what is the purpose of Earth existing in the exact good place at an exact same point at an exact good temperature at an exact good atmosphere and all the good favorable conditions. Are we the alone people? Are we the only sole people and intelligent life form present in the universe? Well, these are many questions regarding to it, and that is the answer. How you can get it is the study of the Big Bang. So the thing is that, are there any rules of chemistry or chemical reactions, astrocosmochemistry, which is contrarian to the different of the earth chemistry? Well. There is a difference. Okay. There is always a difference. Let me tell you, the laws of physics are contradicted in the laws of quantum physics. Okay. For example, let me give you an example that, for example, I am sitting over here. Okay. but according to quantum mechanics I am not even here. Okay, like that is how the contradictory thing it is. You can see me, but according to quantum mechanics you are not. For example, I am, I am touching this hand, but according to quantum mechanics I am not touching hand, the hand is touching myself. This is something, there is very very different. Even the particles which are actually having there now, for example, quantum mechanics also goes like this is not even possible, my hands are also not possible over here. This that how am I reacting to the nature, how am I behaving, or how am I moving my hand or something, what is the position and the velocity which is cleared in the Heisenberg uncertainty principle. So these are all very big mysteries there in astronomy and quantum mechanics. So the same way, the chemistrical laws which are followed in the in your laboratory chemistry, many of those laws are followed in cosmic chemistry as well. But after a certain amount of time, when you go in quantum chemistry, the laws all which are made over here in chemistry or in astrochemistry, these all laws are totally contradicted. These all laws are of no use anymore. Okay, so this is how the fluctuation occurs. Okay, so that is how it goes. Now let me tell you that what is the how the Big Bang occurred, or how Big Bang is how we are having proof that yes, 13.8 billion years ago there was one big bomb blast which is actually called as the Big Bang. Okay, now do anyone know that who coined the term Big Bang? It is a very weird name, right? Big Bang, that how it is a very very weird name, that how Big Bang occurs, like how it goes. Like Big Bang means the very big blast of energy, something like this. It is not having scientific explanation to it, but a very literal term, Big Bang, big boom, that's all. So there is, for example, the Big Bang which occurred. Okay, the term was actually coined by Friedrich Hoyle. Okay, now this is why I'm telling you this. I am not at all interested in names, and not at all interested in years, that when it was termed, how it was termed. But the thing is that over here there is one big thing. Professor Jayant Narayakar, he is actually a scientist, and he was the director of IUCA as well, I think, or on a very senior level of IUCA position. So he studied from Cambridge University. Okay, and his mentor was Mr. Friedrich Hoyle. So this was actually a very very good. This was actually very very good to know about this particular thing, because I attended his personal sessions, and when I had a when I had a look back in his life, I got to know about this particular thing. So it was very very interesting for me to study his research papers as well and his citations. So, anyways, now let's get back to the topic of Big Bang. So, 13.8 billion years ago, there was some big energy. There was some big, dense mass, or some kind of particle which was there. When the universe was the fraction of a fraction of a fraction of an atom small, and suddenly a big bang occurred on a very quantum level, and from that quantum level it expanded at such a vast background, that within zeroth of a zeroth of a zeroth of a second, which we call it as a billionth of a fraction of a second, that particular small energy. For example, this is a football. Okay, now this football is, imagine this football is a universe. Okay, the universe is of a football size right now, only a size of a football the universe is right now. Within the billionth of a second, this football got expanded from a size of a football to a football stadium. So the growth of the universe was that vast. It was growing very very extremely fast, and it is accelerating till today. Okay, with a constant growth. So the universe is expanding, and it is stretching the fabric of space time like this. Okay, so that is how it goes actually. And I actually wanted to know that well, I am very very interested, like you, that how it goes, that how this particular the mass might have happened, or this kind of Big Bang might have happened. So we all scientists have given many many citations, many many studies were performed actually by the scientists. But there are many many theories which were given by scientists, to be honest. But many theories weren't agreed, because it was not accurate according scientifical way. So that is why the thing is that that is why when Big Bang concept came, when the concept of Big Bang came, everyone was very very astonished. First of all, it was not much got popular, But when we started getting proofs or the evidences of Big Bang, we got to know that yes, Big Bang did occur, and still today we believe that Big Bang was the real thing that happened at the starting of the universe. Okay, now the first thing is that you can see a diagram over here, right? The diagram was over here. You can all see that how the diagram goes. You know, this diagram is actually very, very common. You all have seen this diagram. I'm pretty sure about this. And sorry. So the thing is that how the inflation occurs over here, that is the explanation of the diagram. Now let me go to the proof. Well, the explosion that happened is still a mystery. Why it happened? It was actually said that one matter particle and one antimatter particle got into each other, and then it created a chaos which happened, which went into the chain reaction. And all those, after the chain reaction, when the universe got cold, that particular thing, that particular coldness of the universe, that led to the current universe, which is stable and following the physical laws, physical entities, and chemistry laws at the same time. Okay, so this is how the story of universe goes actually. So now, what are the major evidences of the Big Bang? There are four major evidences, to be honest. Let me tell you that there are these four major evidences have been studied in since last 1 century. We are getting proofs of it since last 1 century. Okay, I have been seeing the chat box since last 5 minutes. Everyone is going towards the microwave, cosmic microwave background, CMB. So CMB has been a very, very interesting topic since the very start when we started getting proof. Actually, CMB was the first proof that we got that universe had an explosionist and a very, very unstable start. The birth of the Big Bang, or the birth of the universe, the Big Bang, which we call it.
Guys, I think there is some technical issue with Soham sir, so he's going to be back in a minute. Just hold on, he's going to be back within a minute. Hope you guys are enjoying the session as at this point. So please let me know in the chat box. Give us a rating from 1 to 10 about this session. So there's some technical issue, and Som sir is going to be back in a minute. Okay. So if you guys are new, I know many of you guys are new. So please click on the subscribe button. So we have amazing content about astronomy and space science. Many of these content are student, generated. Okay, so a lot of interesting content are there for you to consume. Okay, so let me just give a call to Soham sir right now. So many issues there. Yeah. Guys, I'm not sure what is slow chat to turn that on. Okay, but sir is having some difficulty. We are not sure what the difficulty is. So it says that he is connected, but unfortunately he is not connected. So we'll just join in a minute. Okay. Nice, nice that a lot of you guys are loving the class. Thank you so much. Thanks, Immaculate. So hit the subscribe button, the like button, the notification button. What other buttons are there? Whatever it is, please hit them. If there are any other buttons, please hit them. Soham sir is talking. That's exactly what I also hear, but I'm not seeing him in the live stream. Okay, he's back. He's back. Hi Soham.
Hello.
Yeah.
Well, there was a technical issue. I
Yes.
hope I'm audible right
Yeah,
now.
yeah, you're audible. You're audible now. So
Great,
we'll have
great.
to finish in another 5 minutes, Sean. 5 10 minutes.
Okay, sure. No
Okay.
problem. No problem
Yeah.
at all.
Yeah.
Fine.
1 second. Let me bring your screen on share.
Okay, I'm sharing the screen too. I hope just give me a thumbs up, guys, that I am
Yes.
having my screen on.
Yes. Yes. Your screen is on.
Yep. Okay, great,
Okay.
great. Sure. Okay, okay, guys. Time to hit the space journey again for next few minutes. You are going to be with me. So, okay. So let's start. Well, there are four proofs now. Cosmic microwave background is the most thinged or most that the most discussed actually proof of microwave background. Redshift of the galaxies. Now redshifting is actually a process of Doppler shift. Okay, now Doppler is a physical concept that how it goes. Now Doppler shift is actually, there are two things: blue shift and red shift. Now blue shift is causing that the if the object is coming near, for example, there is always this one very very good example that one person is standing on the road and one ambulance is going like this. Okay, now ambulance always makes the sound of its like the alarm sound which is there. Now when it is coming towards the particular person, the wavelength is causing blue shift. Okay, the wavelength causing the blue shift is the evidence or the proof that the particular object is coming near to you. And if the ambulance is going this way or far away from the person, then the evidence is called as the evidence causing the observation is in red shift. The red shift means the object is going afar. Okay, so the universe is going afar from each other. Okay, every object is going afar from each other right now, even right now. Sorry, so if there is a laptop on your lap or you're on your table, mobile in your hand, the even the mobile is going away from you, but you don't know it is going, but you don't know. Okay, that is the power of universe which is going on right now. That is how it is touching on you. We are not knowing it because it's a very small minor change, very very small negative change, but it is happening. It is causing, it is there because we are getting it. We are getting the observational results of it. Mixture of chemical elements. Okay, now mixture of elements, chemical elements, as I told you, the sun, the star, the nebulas, and all kind of things. Looking back in time, for example, now a basic thing which I want to ask you: what how much time it takes from earth to sun, sorry, from sun to earth, the time of light that it takes, the light time that takes from earth, from sun to earth. Okay, what is the time that it will reach? Okay, that is a basic question. You might have known this is a very, very general knowledge question. Okay, and that is how I can prove it to you that how the evidences of Big Bang are there. Okay, so it is like 8 minutes. Yes, this there is someone presenting. Yes, 8 minutes. 8 minutes. Great, great, great. So 8 minutes and 26 seconds to be precise is the time taken by sun to earth to reach. Okay, now if you, for example, right now if there is any window, go to the window and look at sun. Okay, now what are you going to do? If you are watching it right now, what is it doing? The thing is that you are watching the sun which is 8 minutes and 26 seconds ago. It is not right now because it will take another 8 minutes to and 26 seconds to reach. Okay, so you are looking at the sun which is there in the past. It is not the present sun. So if you particularly right now, if you right now just take the sun and displace it somewhere, if you take out this sun, okay, you will not even know that the sun has disappeared for next 8 minutes and 26 seconds. The light will still be there, although the sun is gone, but still light will be there for 8 minutes and 26 seconds. After 8 minutes and 26 seconds, this particular you will experience darkness. Then you will get to know the, oh, sun is gone. So this is how it is going. This is how the major evidences of the Big Bang is there, because earth, because the sorry, the universe is expanding. Okay, is it possible to see the present sun? Yes, it is possible. Just go to the sun. Just go to the sun, you will be able to see the present sun. Okay, okay, now we are going to go to the next slide, which says that the mysterious dark matter. Okay, so this is a very very interesting topic. Okay, so well, the thing is that how the dark matter goes on. Okay, how it goes, that how the dark matter is made. What is the dark matter? How it is? How it can be analyzed? The dark matter is actually a matter which is made up of WIMPs, WIMPs, weakly interactive massive particles. This is WIMP. Now, this what is this particle? We don't even know of. This actually is a particle which doesn't react with any of the atom. Okay, which doesn't react with any of the physical universe. Right now, there are this is my hand, right? There are millions of particles which are going in and through my hand right now. The dark matter, dark matter particle which is there, it is going in and out with, I don't even know, even with you it is present everywhere, because it is covering 80 percentage of the universe. Whatever we are seeing, the stars, the universe, the galaxies, the nebulas, the even the door, the earth, the buildings, everything, each and everything which you can see, it is all just the 4% of universe. You are just a part of 4 percentage of that universe. The 80 percentage of the universe we don't even know. So just imagine the adventurous and thriving ride it will be for the research opportunities which are there in astronomy. Okay. So, anyways, after that, scientists are trying to prove it up actually. We are trying to gain the momentum in that particular field. Well, so the content of the universe, you know of. Now there is next particular thing is that, as I told you, yes, there is one good point that the dark matter is made up of non-baryonic matter. Now what this particular thing is, baryonic matter is nothing but electrons, protons, neutrons, and your atoms, your carbon particles, your neutrinos, no, sorry, not neutrinos, it is different one. Hydrogen, all the periodic table contents which are there, all are baryonic matter. Non-baryonic matter is the particles which doesn't react with the particular particle. For example, muon, bosons, zeptons, leptons, quarks, then antiparticles. These are antiparticle is right now not, we can make it, but we don't it is not present in the natural universe, so we don't know about it. So non-baryonic matter is also it is a term which is coined in physics for dark matter. Okay, always remember this particular thing. Now how, if we don't know that if it doesn't reacts, if it is not visible, if we can't feel it, then how we can see it present? It is there? How we know that it is even there? At least we know the air is there because we can feel it, right? But if we can't even feel it, we can't even see it, we can't even get the results in the radio astronomy. We even after experimenting we can't even get it. So how do we know that dark matter exists? Because there was one thing, Chandra X-ray observatory was there. It was actually it observed merging two galaxy clusters. Okay, there was a galaxy cluster which was merging, which is called as the Pulit clusters. Now two nebulas were merging like this. Okay, two nebulas were merging, but suddenly, as we all scientists thought that it will merge into each other and it will form a bigger cloud. Okay, they will collapse and they will form a bigger cloud. Okay, but it didn't happen. As you can see in here in the picture, it just came till here and it is staying over here. And after that, we can experience redshift into it. So it is going apart. So this is very very mysterious behavior, because the gravitational force should have led that particular cloud to merge into each other, but it is not the case. It is very very different case. So it is actually the opposite one. So it was actually not possible, so this has led that something present is there, something is there in the universe which we don't know of, which we don't even have any idea about. So that's when dark matter came in. Okay, or dark energy, dark matter and dark energy, these are two terms. So now let me go in the, as we are having some less time, so let me go in the depth of applications of astrochemistry in quantum mechanics. Now this, let me give you a brief idea about this. I will not go into much depth because this is actually, let me tell you, if you search this particular thing on your Google, okay, you will find that this experiment has won the Nobel Prize. Okay, this particular experiment is called as the Super Cameo Candé. Okay, Super Cameo Candé, or the Super Kamioka neutrino detector experiment. It is located in Japan. Now, what these guys did, this is a very very fantastic and engineering marvel which you can see over here. How this happens? Now you can see there is a gold plated bowls present or attached on all over the place. Okay, and there on the left side of the image you can see that there is something bluish. This is bluish, nothing but the water. There is 50 tons, 50,000 tons of water is actually filled in this container, in this huge container. Okay, and then you can, and then they have detected neutrino. Neutrino, what is neutrino? Neutrino is not a neutron. Okay, neutron is different. Neutrino is a subatomic particle which cannot be detected. There are millions and millions of neutrinos that sun is actually making. Sun is the preparer or the factory of neutrino maker. Okay, it prepares thousands and thousands of neutrinos in each and every solar flare it emits. Okay, neutrino goes every, each and every, thousands and lakhs of neutrinos, billions of neutrinos goes from this palm of my hand each and every millionth of a second, but I don't even know of. Then how can we detect, how can we detect it? There is this golden plated bowls which are there, right? These golden plated bowls are nothing but photo emitters. Okay, photodiode emitters, these are actually that. These are detectors of the particular thing. Now when water is present, why 50,000 tons of water? This is actually, and one more thing, this tank is actually buried. Okay, they actually dug up a whole mountain. Japanese space agency and NASA, American energy department of energy, American department of energy, they funded 100 millions of dollars. They dug up a particular whole mountain from inside hollow, and then they inserted this particular super cameo cande into the mountain. This mountain is 1000 meter or 1 kilometer inside the ground. Okay, this is because to prevent the extra sun layers, to to avoid the extra sun layer, and only neutrino should be detected. For that, this particular thing was there. Okay, there is neutrino for every boson type. Well, this is actually a this is actually a quantum mechanical law. There is neutrino for each and every boson type. Boson is different, neutrino is very very different, but yes, this is actually a true statement I saw just in the chat box. So well, we will be discussing the quantum mechanics in depth. I am really very interested, this is my favorite subject. So anyways, so 50,000 tons of water is filled inside super cameo cante, and when neutrino comes in, now neutrino can go at any extent. Okay, even if you close the door, still neutrino will come inside. There is no boundaries to neutrinos, it can come and go past anywhere, anyhow. It is having no boundaries, anything can't stop it. So when it goes inside the mountain, okay, when it goes inside this particular water, okay, there is because the neutrino get trespassed with the water, there is one energy which is called as Cherenkov radiation. Okay, there is one particular energy which is called as Cherenkov radiation. Cherenkov radiation is a blue color light. Okay, I will not go into this because this is a nuclear physics part. Cherenkov radiation is nuclear physics part. Okay, so Cherenkov radiation is actually a blue color light which gives you the proof that yes, there is something which is creating energy in mega electron volt. Okay, now this super cameo cande is having the capacity to go from mega electron volt to giga electron volt as well. Now here you can see in the image over here that the golden plates which are there, these are actually photodiodes. Okay, these are, there are 13,000 photodiodes present in the whole container. So there are 13,000 eyes which are looking that how the particular neutrino is getting detected. Okay, so this is an engineering marvel which was created by 49 universities all over the world, including the Japanese one. Japan had a very big contribution into this, and Japan won a Nobel Prize in I think 2011 or 12 in this particular in this super cameo Kande experiment. Now you can imagine 2012, we didn't even had any idea that this particular thing happened. Japan started this thing since 1989 maybe something, so you can imagine how back it was. Okay, so as soon as the neutron detection happens, the core collapses. Okay, and this is the initial starting. Scientists discovered that neutrino collapse is the initial starting of a star dying as well, or a supernova which happens. It is also the thing. Okay, so so, well, according to you, now tell me, according to you, what is a neutrino? I have told you that how it goes, that how, what is the functionality of the neutrino, or how neutrino is there. Okay, so just tell me that how it goes. Well, the thing is that apart from this, how did you experience it? I hope I am very very clear regarding super cameo cande. Have you got it? Have you understood even at least the 50 to 60 percentage what I'm saying? Okay, because that is very very easy to understand, and it is very conceptual. So according to me, it should be very very interesting to you. So let's just tell me that how it goes. Neutrino goes faster than light. Well. There is really one good point which I got. Cherenkov radiation, which I was talking about. Now this kind of radiation, okay, this goes faster than light. Okay, in water, Cherenkov radiation is having more speed than the speed of light. It goes faster than 3 multiplied by 10 to the power 8 meter per second square. Okay, and in vacuum, when you pass this Cherenkov radiation or a blue color light in vacuum, it goes less faster. The speed decreases of Cherenkov radiation than light. Okay, so the water acts as a medium for Cherenkov radiation and a very good purified results. For a good results, we need water. So for this, okay, for this, there is like we for this particular thing 50,000 tons of water was used into this particular experiment. Okay, now this is actually a blueprint of of this particular sorry, so this is actually a blueprint of Super Kamiokande. Okay, so now Super Kamiokande is having a tank. Of course, you can see that's a cylindrical tank inserted like this box, this box it going inside the mountain. Okay, so this cylindrical tank going inside the mountain, 50,000 photodiodes, 13,000 photodiodes into it, 50,000 tons of water into it. Okay, and there is the photomultiplier tubes are there. Okay, there is photomultiplier, inner detector is there, outer detector is there, water purification system is also there, because you need 100% purified groundwater. Okay, groundwater, remember this word, groundwater. You need 100% purified groundwater you need over here. Okay, control system is there, electronic hubs are there, top of tank is there. So this is the whole blueprint that how Super Kamiokande experiment goes on. Okay, neutrino are the same members of the group of the electron. Well, no. See, neutrinos are electron neutrino, muon neutrino, and tau neutrino. These are three types of neutrinos which are there in the quantum mechanical part. So I will experiment. I will tell you this afterwards because there are many other things. I will end up with time if I start with quantum mechanics. It is a very big branch, but it is at the same time it is extremely very very interesting. Okay, so apart from being interesting, this is how I will go continue with our Super Kamiokande. 50,000 tons of water. This blue radiation, blue color light. Okay, this blue color light is how it goes. Okay, Cherenkov radiation is experimented in this, and nuclear physics is having the most applications of Cherenkov radiation. Now, next thing, the boats. You can see the boats are over here. The boats you can see, because there is too much water. So to clean the water, if anything goes wrong, any photo multiplier tubes, there are so many photo multiplier tubes. 13,000 to 25,000 photo multiplier tubes are there inside the present in the tank. So if anything, any maintenance thing is there, and if water is there, without draining the water, you need to take these boats, and go inside and check what is going on. So yes, this is actually a very big task to maintain this particular thing. Okay, so yes, there are 49 institutions, NASA, JAXA, and ESA are there to control this particular thing. And yes, one more thing, Super Kamiokande is going to go in upgradation to become Hyper Kamiokande. Now there is a capacity of mega electron volts to giga electron volts right now, but it wants to go above giga electron volts as well. So for that, upgradation is there going to happen in this process. So anyways, so now let me just ask you some minimalist question. Now, enough with knowledge. Let's start with our own very good topic. So, are you all interested in aliens? Just tell me this one thing. Are you interested in aliens? Anyone? And if yes, then tell me that why? Why so? Why are you interested in aliens? What are you exactly going to talk to aliens? What are you going to talk to aliens if you actually meet them? Like, what do you think? How are you exactly going to communicate with them? If you get a chance to interact with the aliens, by the way. So can we communicate with the aliens? Okay, I'm getting a lot of yes, yes, yes. Great. Okay, everyone is of course everyone is there. SETI, yes, we are going to go into that particular area. SETI, we are going to go into it. So your aliens are very much interested. Area 51. Okay, we have started with Area 51 Pentagon, right? We are all interested into that cause they are yes, cause they're aliens. Okay, so okay, now aliens are actually a very interesting topic since the very start of astronomy. Even when in 1969, when US went to Apollo, when started with Apollo missions and went to moon, even then we were interested in the aliens part. Okay, So it has been always a very big curiosity for us, that is there someone else, is there someone else, there is a possibility to exist, we can't observe the whole universe. Well, there, yes, that is very very true, that is very very true. And because our limits are very very less, we are not advanced into that particular system, that that we will understand and we will get to a conclusion that yes, we know all everything from the universe. Just now I told you that there is 80% of the universe we don't even know of. So yes, that is a very big possibility. um, so after that, how they know that that can be, they can be live in the space? Yes, so now there is very very big thing now. This is a question. What do you think the aliens might look like? Well, this is a very what I can say is very very imaginative question. Each and every one of us might be having a very different aspect to this, so no worries. But still I will ask you, what do you think? What might be their color? Like green, they might be short, they might be having big ears or something. That is, that how you imagine the aliens? Is that so? So, anyways, uh, but other microorganisms can exist. Yes, this is a very, very matured answer actually. That at least microorganisms can exist, and that is a bacterial form of aliens can exist. Depending on the surrounding, depending on the atmosphere, depending on the environment, that how the aliens are there. Okay, so now SETI. Now SETI is here. That is going here. Here is how we are going to talk. This is how we are going to talk about SETI. Search for extraterrestrial life. Now we don't call it aliens in scientific language. We call it extraterrestrial life. Extraterrestrial means the life which is beyond this particular terrestrial place called as Earth. It's called as extraterrestrial life. So when we search for this particular thing, there is one institution called as SETI. Okay, so you can see a lot of pictures over here. I have created a collage of the pictures over here. What is it? The first is that there was one experiment. Let me give you a brief overview that how the experiment was there. The experiment which SETI performed, it was like they sent, they sent a particular radiation catcher. They particular sent the bacterial catcher in the space using an weather balloon. Okay, now weather balloon is filled with helium. Okay, now helium is actually lighter than the air. Okay, so when it goes up, okay, you all have seen helium balloons that it goes up in the air. There are some balloons which drop down and there are some balloons which go up. Okay, so thing is that the helium balloon which is there, it goes actually up in the atmosphere. It goes almost about 25 to 30 kilometers, okay, in the atmosphere. And there was one bacterial catcher. Okay, so now that particular bacteria was catch. You can see this picture over here, that how crane is lifting up that particular thing, how it was going. Okay, so now there is a payload attached at the bottom of the helium balloon. Okay, and then it goes up. Okay, after it goes up, it comes down, because helium balloon goes up to a certain level, it gets it bursts out, it blasts, and it comes down. Now when it comes down, the payload also comes down. Now it shouldn't be having any it shouldn't be having any kind of a hard landing. It should be having a soft landing. Okay, so to ensure that the payload shouldn't get damaged, there is a parachute comes after a particular certain level, the parachute it's open, and then the payload comes down to the ground of Earth. Okay, after extracting the particular payload, we study it. And at that time, when SETI scientists sent the particular bacteria, Earth kind of a bacteria, sorry, bacterial catcher, when they sent it, there was some kind of different air molecules which was catched from the upper atmosphere of Earth. Now, from 25 to 30 kilometers above, you can imagine that the oxygen level is very, very less. The atmosphere is very, very less. The air is very, very less. So we can't sustain there. Okay, I can't sustain there. You can't sustain there, because we survive on oxygen. We need oxygen, and if oxygen is not there, we can't survive. Even the bacteria, most of the life forms, most of the amoebas and the unicellular life forms are there. Everyone sustains on oxygen. Okay, so now when the bacteria which are there, which were actually catched, so at that time they came down. Okay, after catching, when they analyzed, they got that the DNA or the particular genes of the viruses of the bacteria were actually very different from the bacteria which are present from the Earth. The species of each and every bacteria was very very different. That means the extraterrestrial life forms or the aliens are present on the upper atmosphere of the Earth itself. As soon as you leave the initial layers of the Earth, you will find you will find very very different formats of life forms. Okay, so that is how we are going to learn about it. That is how SETI scientists did it. Okay, so for even to understand that particular thing on different planets, this is the story of Earth, but we need to understand it in a very different formats on different planets, on different solar systems, in different galaxies. So for that we need radio astronomy. Radio astronomy is nothing but the second picture. You can see antennas, a dish, a line of antennas which are there. So for that, to analyze that in radio format, you need to have the radio astronomy knowledge. So that is how you can understand that how whether extraterrestrial life is existing or not. Now there are two pictures. Okay, three pictures are which are there actually. The antenna pictures are over there. Now two pictures are very very consecutive over here. One is there the diagram of the man and a woman is there, and second is the golden CD which you can find over here. This diagram was made by the the very very aspiring scientist. I am fond, I adore that particular scientist a lot. He is none other than the Carl Sagan. The Carl Sagan, he is a scientist, he who is having a very good knowledge in planetary science. He is having a very good knowledge in planetary science. He delivered a very good lecture, the Cosmos. The series of the Cosmos was made by him. A book written, named by Cosmos, was also written by him. So the diagram that the when Voyager, you all know about Voyager, right? Voyager, that particular satellite went outside the solar system. That particular scientist, made this particular diagram, and the CD, which leads to the address towards Earth. The address towards Earth from any point of universe, you can actually come to the Earth and you can see there. That is how the address of Earth is actually written and coded in that particular CD. It was made, and it was the idea of Carl Sagan to do it. Also, to give the information that how humans look like, how humans are made. This is also the diagram that was provided, and this particular information is still present on Voyager satellite, which is right now outside the solar system. So this is how it goes, and this is how the SETI scientists are actually performing in very very different formats. Okay, so the radio astronomy, each and every thing which is there. Yes, Voyager 1 and Voyager 2 are still there. Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and even there is New Horizons telescope. New Horizons satellite. These are all present, and these are right now outside the solar system. So let me take. So guys, if you have any of the questions, you can all let me know right now, and then we can go towards your best and the most interesting part, the quiz questions. Okay, so for that, before that, let me tell you, you can all follow for more such kind of things. Like Astronautic Institute website is there, astronauticinstitute.com. You can just search and you can join us. Also, you can join our community. We are having a WhatsApp community as well. Okay, you can actually join that WhatsApp community. You can all, Vinod sir, let it know. I will tell him that you can put the Astronautic Institute
Yeah, buddy.
WhatsApp community over there.
So what you can do is that
Yes,
you can leave a comment in the video. So guys, you can just check out the links for Astronautic Institute in the comment, or sometime later I'm going to put it up in the description, and you guys can join the community. An amazing community. You guys are doing a great job.
indeed. Thank you, sir. Thank you very much, sir. It was really a good session, a very great audience, I must say, and a very, very, very active audience. I was really great. I was very, very astounded to see that the knowledge of the students which are there, they are already knowing many, many things. And really, I was very much appreciated over here. I was glad to be a part of it and was able to deliver a lecture over here.
Fantastic, man. Really, really happy to host you today. So thank you so much. I hope all of them, got so much of value out of it. So it was kind of like a lot of eye opening for me. So thank you so much, Soham, once again. Please do share your details as a comment in the YouTube video. Okay.
Indeed, indeed.
Okay.
Surely, surely. Thank you
Fantastic.
very much,
Hey,
all.
I think we are going to skip the Q&A because we are running out of time. So usually we try to finish in time. Usually it jumps for another 10-15 minutes. So what we will do is that we will quickly catch on the Kahoot game and then end the session. So Soham, thank you so much one more time. We would really love to host you a few more times during the year. So looking forward to collaborating more with Astronautic Institute, man. Huh?
Surely. Thank you. Thank you very much, sir.
Thank
I
you.
thank a lot to LearnSpace as well. Thank you, children. Thank you very much.
Thank you. Thank you, guys. Yeah. Okay, guys. So here is the Kahoot screen for you, for those of you who are kind of like looking forward to the Kahoot. So let me just share the Kahoot screen. Yes, here is the Kahoot screen. So I think you guys can see the Kahoot screen now in the screen. So guys, what I want you guys to do is, I want you to join the Kahoot. Let me just bring my screen to the Kahoot screen. Hold on. Okay, so we have the Kahoot screen here. So let me just hide shared screen. Okay, guys, give me a sec. I think it's in mirror mode. Okay, super. So guys, so those of you who are new to playing the Kahoot with us, so please visit this web page kahoot.it. So it's shown up in the screen. So I'm just highlighting it right now. So kahoot.it. Okay. So and what you do is that you enter the game pin 423590. So once you enter the game pin, you should be able to join the Kahoot. So in the Kahoot, what we are going to do is that we are going to be kind of like revising a few of the questions that we had learned out over here. So it's going to be about 10 questions, and in those 10 questions, we would revise some of the topics, some of the things that Soham sir had taught us during the day. Okay, please join the Kahoot. And as you guys are joining the Kahoot, I wanted to introduce what we are going to do with the iSKY Astro Club for this year. So, one second, guys. Okay, so with regards to the iSKY Astro Club, this year we are starting the iSKY Astro Club uh, as two classes per year, per month. So, and the focus is going to be on learning astronomy and space science through current affairs events. So, we are looking at current affairs. We are looking at astronomy and space science related events and learn the science through that. Okay, so you guys know that I'm a huge history buff, so I like reading stuff. So ever since the Quiz Premier League happened, and we were kind of like thinking of launching the Quiz Premier League as a current affairs program with Kahoot. So I was thinking, why instead of doing current affairs, why can't we do the iSKY Astro Club using current affairs? So that's what we have launched this year. So we are going to have two classes, first and third Sunday every month. We are going to have the iSKY Astro Club. So on the first Sunday, we are going to have a discussion on what are the things that has happened in the previous month that are kind of like important and significant in the field of astronomy and space science. So and in the third Sunday, we are going to play a Kahoot. So every month we are going to have a Kahoot, and in between, I'm thinking we will invite a few more interesting speakers to talk on interesting topics for you guys. So all of this we are starting in August. So August, September, October, November, December, January, February, March. So like last year, we're going to have an 8-month program. So we are going to have about 16 to 20 classes, my expectation. So for the 16 to 20 classes, we are going to charge you 1999 rupees. Okay, 1999. So and that's about less than close to 100 rupee per class. So I really want all of you guys to take up this opportunity and join the iSKY Astro Club. I know a few of you guys, so it's going to be an online session every month, and it's going to blast. It's going to be a rock and roll session for this year. Okay, so it is open for all from grade 5, grade 4 onwards to participate. Okay, So we have 22 people here. Lavanya, so all you need to do is just go to this webpage, kahoot.it, open it up in a new tab. Okay, you open it up in a new tab and then enter this game pin 423590. 423590. We have 50 people have already joined. Okay, so quick, more people can join. And once you have joined, we'll play the Kahoot game. Okay, so okay, guys, I think as we are getting a little ahead of time, so I'm going to start the game. So, those of you who are joining in a little late, the Kahoot game pin will be shown at the bottom of the screen. You can just, visit the app kahoot.it, okay, and enter the game pin. So, we are playing a game called Color Kingdom, where let me start the game. So, what you need to do, the answers are going to get shown in your screen. So question and answers, you're going to answer that, and once you get the right answers, okay, so you're going to get flags, and you can use the flags to win land tiles and spread your team's colors. Okay, so the team which has kind of like captured the other team's flag, is going to win. So you just need to surround yourself around their castle, and if you had surround yourself around your opponent's castle, you are going to win. Okay, so you can also surround an area to claim the entire area. You don't need to capture all the tiles in it. If you just surround it, you will be able to claim the entire area. So here is the astrochemistry Kahoot. Okay, you're going to play it for 7 minutes and call it. So Sashmit is the first one. Sashmit and Sankalp has taken up the same place. Come on, guys, move over to the other area. Very good. Team Red is kind of like taking up a large role. Very good. Team Red and Team Blue are kind of like fighting it out. So guys, I have shared the details about iSKY Astro Club in the scroller, so you guys can see that. So please visit learnspacescience.com/iSKY Astro Club, and you can enroll for the entire year at just rupees 1,999. I'm also going to be sending you guys details about the certificates as a WhatsApp to you guys, and it will also be kind of like updated in the description column after the live session is over. So please, so we are going to be giving you guys an open certificate, so you guys can edit your name, your details in the certificate as you wish. So it would be available in the descriptions. So check out the description a little while later. Very good, guys. 4 minutes down. So it's a healthy competition. I think team red is kind of like making inroads, whereas team blue is kind of like getting on more tiles. So this year for the iSKY Astro Club, we are going to have only 100 students. So usually, as you guys know, so our classes would have 300, 400 students. So last year we had more students in the iSKY Astro Club. So this year we are only going to have 100 students because I have kind of like planned for like 4 or 5 different activities along with the students. So and it's kind of like really difficult to manage more with them with more students. So this year we have thought we would just restrict ourselves to 100 students. So if you guys are interested, there is also an option to enroll for the iSKY Astro Club at paying a monthly installment of 500 rupees for 4 months. So that option is also available to you guys. So, as you all know, we are into kind of like conducting astronomy clubs in schools. We run after school astronomy clubs. We run the iSKY Astronomy Club in school, and we also run mobile planetarium shows. So, if any of your schools are kind of like interested in starting an astronomy club or conducting the mobile planetarium show, you can just reach out to the number that's in the scroll so that we can help your school do it. And team blue is on fire. I think team blue is going to win the session. Okay, almost closing time. So we still have 1.5 minutes left, and team blue is kind of like decimating team red. Come on, guys, come on. Okay, Sankalp has taken the fight to team red. If somebody can help Sankalp close. Come on, you guys have 20 people in the team. Team Fire has captured 25% of the board. Last minute purge by Team Fire. Okay, Team Fire is doing a good fight back. Let's see what's going to happen. Thank you, Shankar. The last 30 seconds, guys. Last 30 seconds. Last 30 seconds. Okay, guys, there was some small technical difficulty. Your screen is coming back now. 8, 7, 6, 5, 4, 3, 2, 1. Yes. Let's see. Let's see the scores right now. There's some issue with the Kahoot platform per se. So in 7 minutes, I think Team Blue has got the largest tiles. Let's see. 27. Okay, Team Blue with 29 tiles. Team Ocean with 29 tiles wins it creates the largest empire. Really, really good. Okay. Superb. Superb, guys. So guys, hope you enjoyed the session. Okay. Regarding your certificates, like I told you, I will update the certificate in the description. Okay. So you can get the certificate. It's an open certificate without your name, so you guys can edit the certificate in your phone editor, or you can use a PowerPoint editor to edit your name, your class, and your school, and share it with your people. So in case you are kind of like sharing it on social media, so please use these credentials. Okay, 1 second. So let me just show you the credentials. Okay, so we are there in YouTube, Facebook, Instagram, and Twitter at Learn Space Science. Okay, so use the hashtag Learn Space Science. So and share it in social media. We'll be more than happy to see your certificates there. And I'm going to be sending you guys a link to write a small review about this program. So please do write a small review about this program, and don't forget to join the iSKY Astro Club for sure. Okay. So thank you guys. Thank you so much. And we would definitely we would be back. Okay. To conduct more amazing workshops for you guys. Okay. So with that, I'll call it a day. Thank you so much. Happy Independence Day. Jai Hind to all of you guys. Bye bye.